This video describes how an MVD can be generated by linking IDM and bSDD. Hello, I am Gang Lee, project leader of this project. Our project team is comprised of members from 3 organizations: Jae-eun Jung-dae Kim, Seung-woo Son, and myself from Yonsei University, Koo-tae Kim, Eunhee Kang, Kyung-jun Kang, and Elena Gerasimenko from Cospec Innolab, and Kyung Kim from BIM Peers. I'm going to describe the background and problem first, and will propose a solution. Then I'll explain how the proposed solution was implemented as a software application and demonstrate how an MVD can be automatically derived from an IDM linked to bSDD. Background and problems. ISO 19650 Part 1 defines the information management process. ISO 19650 Part 1 defines information requirements and issue specification as the first step of the information management process. ISO 29481 Part 1 Information Delivery Manual, IDM, is the standard that specifies the method to define information requirements. So ISO 19650 Part 1 defines or requires the submission of information requirements, and ISO 29481 Part 1 specifies the specification method. So the relationship between ISO 19650 Part 1 and ISO 29481 Part 1 is complementary. However, these 2 standards are not the only ones in the loop, collaborative loop. As a result of the information requirement specification process, we'd like to define information requirements in an explicit form, such as in IFC. The subset of IFC is referred to as Model View Definition, MVD, and we'd like to define, for example, information requirements in a form of an MVD. So using an MVD, a subset of IFC, we can formalize information requirements. There is another international standard that we can utilize to define information requirements. That is ISO 12006 Part 3, a schema to define data dictionary. Building Smart Data Dictionary, bSDD, is also structured based on this schema. Using bSDD, we can get terms related and concepts related to the construction industry, and it includes a concept and IFC entities corresponding to the concepts. Actually, the 3 standards, ISO 12006 Part 3 and ISO 16739 Part 1 and ISO 29481 Part 1 forms the golden triangle of Building Smart international standards. So by utilizing all this, we should be able to create information requirements or specify information exchange requirements easily and efficiently. However, there are large gaps between these 3 standards, which makes IDM not reusable and exchangeable, and makes the connections between these standards not machine executable. The main cause is that IDM is not machine readable, and there is no standard data schema for IDM yet. Proposed solution. In April 2019, a project to develop an IDM schema was initiated by Building Smart International. The goal was to develop an IDM schema to make an IDM a standard that is machine readable, applicable, and transferable. Smart. Currently, it's in the CD phase and is going to be soon to be in DIS phase of ISO 29481 Part 3. To overcome the problems that we stated earlier, we can utilize the IDM schema in two different ways. Let's say that we'd like to specify information requirement related to concrete slab. So we may type in slab as an information unit in IDM, an IDM document, and may look for an IFC element that corresponds to the concept or information unit slab, which will be IFC slab. But the IFC slab itself is not an MVD. So to create a full valid MVD, we need to grab all the IFC elements that is related to IFC slab, such as IFC root and IFC GUID and so on. Fortunately, we don't have to do that manually. There is an algorithm developed in 2009, which is referred to as concept-based MVD generation algorithm, and we can use that to create a full valid MVD from an individual IFC element. So how does the IDM schema, ISO 29481 Part 3, help the linking process, the IDM MVD generation process? So again, the first step we had was the specification of information units. So in case of slab, the slab can be saved in information unit name. Then we need to specify the basis schema. In this example, we used IFC as a general basis schema, but actually there are various versions of IFC. So we should say IFC 4.0 or IFC 2x3. Also, we can use not only IFC, but also other open standard data schema as a basis schema, such as CTGML or OpenGIS. Let's assume that we specified IFC 4.0 as a basis schema, and we can now define IFC slab as the IFC element that corresponds to the concept or information unit slab. The last step is to extract a valid MVD from the selected IFC entities. As mentioned earlier, there is an algorithm, concept-based MVD extraction algorithm developed in 2009, so we can use that to generate a full schema. So using the algorithm, concept-based MVD generation algorithm, we can create an MVD, full valid MVD. However, the mapping process between information units and IFC elements proposed in the first method is still manual and makes it very difficult to find an IFC element that corresponds to a specific concept or term that we defined in an IDM document. For example, if we say that we want we need concrete floor, and if you type in concrete floor in IFC schema or floor, you won't be able to easily find IFC slab. You may find IFC floor, but not IFC slab. So we need to should be able to find IFC slab even if we don't have the term slab in our definition or in the information unit. So is there a way to find actually synonyms? Fortunately, bSDD has these relationships between concepts and IFC elements, and if you type in concrete floor and look for a matching IFC element, you can easily do so. So in the second step, instead of manually going through IFC elements, and by elements I mean entities and properties, we can use bSDD as a way to map a concept and a matching IFC element. Then pass the searched IFC element to the last step, the concept-based MVD generation algorithm, to get the full valid MVD schema. The mapping sequence between IDM schema and bSDD is very similar to what we have done with IFC. So the first step is to specify information unit. In this case, instead of using a slab, we used concrete floor as the term to define information unit. As the next step, we define bSDD as a basis schema instead of defining IFC 4.0 as the basis schema. Since the mapping relationship between a concept and a matching IFC entity or element is included in bSDD, the IDM schema won't include the relationship between these two, but those will be searched using bSDD application programming interface API. So what we are going to store using the IDM schema is the result. So we are going to store IFC slab as external element item. The last step is the same as the previous one. Using the selected IFC entity, we can generate a full valid MVD using the concept-based MVD generation algorithm. Implementation. These proposed methods were implemented as a system, XPPM Neo, Extended Process to Product Modeling system. And this is the system architecture. And as briefly explained, we use bSDD API to link XPPM and bSDD database. Seung-Woo Son will demonstrate how an MVD can be automatically extracted from an IDM definition by linking IDM and bSDD.
Hello, this is tutorial video of automate generation of an MVD by linking IDM and bSDD using XPPM Neo. In order to link IDM and bSDD, first you have to define all necessary information unit under exchange requirement ER. In this video, I'm going to show how to link bSDD and information unit. Under ER, you can see information requirement section that you can define information of all necessary information unit and linked bSDD. By clicking this icon, you can add information unit. Double-click this icon and you can write information of information unit on the right side. You can type or copy and paste document to write this. First, you write name of information unit, then data type, and definition of information unit. And if you click this, you can add textual example and image. For textual example, you can simply type or copy and paste the text of document to write this. And for image, you have to click this icon and you select image to upload image. And for linking bSDD, go to external element, then choose bSDD. A small search icon will pop up, and click search icon will pop up new screen called Building Smart Data Dictionary. Then search for the desired IFC element, and system will search appropriate IFC element and then select IFC stairs. And once you select it, the name and definition of IFC element will automatically mapping into the XPPM system under element and comment. And press save to save all information of information unit and bSDD. Using information unit name slab as example, I'll explain in more detail about linking bSDD and IDM. For searching, you don't need to type full name of IFC schema element. You can simply type slab when you're looking for IFC slab. XPPM Neo can import property within IFC element, type desired property on search bar, in this case, which is volume. After searching, then read description carefully and choose desired property by checking a box. You can go through a whole list and select multiple property if you need it. After you select all necessary property by checking a box next to their name, press select on bottom right corner, and the system will automatically mapping properties under the information unit. Even if the name of information unit is different from what you're searching for, the system can still search for desired IFC element that you're searching for. After finish writing all necessary information unit, go to Generate on the top left side to generate MVD. Click MVD icon and Generate MVD screen will pop up, and type desired name for MVD. Then select desired IFC version and click the document that you worked on and click generate. And it will ask for the file path for generated MVD. And MVD will generate under that file path. Using Notepad, you can see all the structure of MVD, a schema of the MVD, and schema will display a form of express model, and all the linked bSDD that you worked on XPPM Neo will show up in this schema. Thank you for listening this tutorial video.
Thank you for your attention.